Howdy, I am Sang-Rae, who is an instructor of Math151 this semester. I'm glad to meet you all virtually. So this lecture is to discuss a core part of the material. We discuss motivating example and concepts and theorems and some standard problems. So this lecture will be followed by further discussions as the semester goes. All right, so let's get the ball rolling. First topic is vectors, vectors on the plane. So a vector is a quantity that has both magnitude and direction, for example, force and velocity. So to illustrate examples of vectors, let me pick 2 points on the plane. So let me pick 1 point, 2, -1. So let me call this point A. And then 5, 4. And then 5, 3. Yep, B. Yes. So we have 2 points on the plane, and let me join them to have a vector like this. So this vector has a direction and magnitude. So to express or represent a vector, we use arrow. So for example, we can write AB with arrow like this. And this point is initial point. And this point is terminal point. We can also use boldface to write a vector. So for example, you can call this A, or vector A with arrow like this. So we can use boldface like this or arrow like this. Okay, a vector is completely determined by its magnitude and direction. So if you translate this vector so that the initial is at the origin, and then terminal is 3, 4. So you are translating this vector, keeping the magnitude and direction, then you will get a vector like this. Okay, so can you distinguish them? Do you think they are distinct vectors? So a vector is completely determined by its magnitude and direction, so no way to distinguish them. Actually, 2 vectors are the same. So this is also vector A. All right, so so there are many ways to represent the vectors, but one good way is to fix initial point at the origin. So if the origin on the plane is the initial point of a vector, then that vector is completely determined by the terminal point. By the terminal point. Say the terminal point P, A1, A2. So then we can now that if we know this terminal point, we can use bracket notation to write this vector A1, A2. So this is a good idea to represent a vector, because once you determine terminal point, then the vector is completely determined, and we can use this bracket and we use the coordinate of this terminal point to express the vector. So here, let me point this out. So actually, here, vector AB, oops. So it turns out that this point is 4, 3. So this vector, our vector AB in the picture, is exactly same to 4, 3. All right, here is a quick example. So for those 2 points, A, 1, -1, and B, 4, 3, we want to represent this vector. So for those 2 points, we have a vector from A to B, like this. As we did in the previous page, we want to translate this vector, keeping the magnitude and direction, so that the initial is exactly on the origin. So we have a vector like this. All right. So once we find this coordinate of the terminal point, we'll be ready to write down this vector. So to find this terminal point, what we can do is terminal minus initial. So terminal point 4, 3 minus initial point 1, -1. Well, you will get 3, 4. That's it. So this coordinate is 3, 4. So the vector AB is exactly, say, let me call this terminal point P. Then this is exactly OP. Now that we know this terminal point, we can use bracket notation, and this vector is just a 3, 4. All right. We can actually calculate magnitude of this vector. The line segment joining A and B has the same length of this line segment. Now that the coordinate is 3, 4, you can think of right triangle. Like this. And this is 3, 4. Now that it's a right triangle, you know, this hypotenuse is simply 5. The length of this line segment is 5. And of course, you can use Pythagorean theorem. All right. So by this, we know how to calculate magnitude of a vector. So if we know the terminal point of the vector, we can use this formula to calculate magnitude of a vector. Suppose your vector has coordinate A1, A2. So say your vector is coordinate A1, A2. Then you can use Pythagorean theorem, A1 squared plus A2 squared. And quick notation is, well, you put this vector inside absolute value symbol. Of course, we are using the Pythagorean theorem. And the only vector with the length 0 is the 0 vector. And quick notation is, yeah, well, you can put arrow on top of 0 or bold face of 0.